welcome to CSE114 Introduction to Object-Oriented Programming, and this lecture is on basics of programming. So we'll look at basic programming concepts. So let's start with the anatomy of a program. That means if you have written a Java program, then what are the different things that you might expect in a program and what's the purpose? So let's start with the first thing here, comments. So the purpose of the comment is to document your program, which means that you can leave some comments so that if there's anyone who wants to understand like what was going on in the programmer's mind, then that thing can be captured in comments. And comments are written so that the compiler will ignore whatever you have in the comments, and the purpose of the comment is just to have the human being understand the logic behind the program. Okay, and then we have reserved words. Reserved words are some words which we should not use other than the purpose those are meant for. So I have some examples in the next slide, and I'll show you like which are the reserved words and what's the purpose of those reserved words. And some reserved words are called modifiers. We'll look at those as well. And then in the program will have statements. So I consider statement as the smallest unit of your program. Okay, so we will look at the statements and we'll understand that. Then there are blocks. Blocks are the collection of statements which we put in the starting and ending curly braces. So I can put an example right here. This is something that goes in between the starting curly brace and the ending curly brace. So whatever statements that you write, it could be one statement or multiple statements that will create a block in Java. And then we have a kind of block that we called as class. We'll learn about classes. So in fact, in Java, everything that you write goes in a class. So if you remember in the previous class or in the previous lecture I should say, we wrote a very simple program named welcome. So even for that very simple program where we were just printing a message, welcome to CSE114 I believe, or you can write any other welcome message or any other message even. So even for that very simple program where you were just printing some statement on the console, that means on your monitor, you needed a class. Okay, so classes are very important, and in order to create class we have a reserved word as well. So in a Java program, expect at least one class. Then in the class, even in that very simple example that we had, which was about the welcome, or the welcome example that we did in the last class, we had at least one method. Okay, and that method was a main method. So in Java program, you might see more than one method, or at least one method should be there. So that one method that you must have in a program to run that program is main method. Okay, so in fact we have that as the last point. So example of a method is main method that you must have. Other than the main method, you can write other methods as well for anything else that you want to do outside the main method. Alright, so let's move on and let's recap. I think I covered the comments in the previous lecture, but we can revise that thing. So in the Java program we have three options of commenting. So there is something called as the line comment. So line comment means that only one line would be commented out. Okay, so if there is a statement that you want to comment out, or if you want to write a comment that is confined to just one line, then you should use this two forward slash. Alright, and whatever you write after the two forward slash, that will become comment. But that comment would be confined to just one line. So if you want to just comment one line, then you use this approach, which is two forward slash. You might like to comment the whole paragraph, And for paragraph commenting, we have these two. We use pair of operators, which is forward slash followed by a star. That is how you will start your comment, and then towards the end you will have a star followed by the forward slash again. So as an example, assume that you have statement 1 that goes in the whole one line, and then you have statement 2 which is a big line again, and this way you have a complete paragraph. Let's say statement, and you want to comment it out, so just do it this way. The whole paragraph would be commented out, and if you just had to comment one line, then you will use two forward slash. And there's one more way which is more standard, called Java.comment. This has this notion like you should start it with the forward slash, couple of stars, and you should end that with just one star and a forward slash. This is more standard actually, and in the standard Java programs, this is the way that usually people follow, which is Java.comments. For CSE114, I believe these two are fine. Okay, you can use either line comments or you can use paragraph comments. If you really find Java.comments interesting, then you can follow that as well. Okay, so now let's look at the reserve words. Like, what are reserve words, and why we should be careful about reserve words. So you can either call them reserve words or keywords. They mean the same thing. Some people call them reserve words, other people refer to those as keywords, but that means the same thing. Now these are the words that have some purpose to serve, and they have a well-defined understanding in Java. So if you use those keywords, then the Java will interpret that in a specific way, right? As an example, let's look at class, right? So class has a specific meaning in Java. So if you remember, we wrote that welcome program this way. Let me reproduce a part of that program. We wrote that program like this. We said public class, all right, and after that we said welcome, and then we did the rest of the thing in this block. So here, whenever you write class, then Java is interpreting it in such a way that whatever you write after this keyword class has to be the name of a class, the name of a class that you're creating. So you're declaring to Java that, class welcome. That means welcome is the name of the class, right? So after this keyword class comes the name of the class. So you cannot use class for any other purpose. If you're writing class in your Java program, then that means it will be followed by the name of a class. Okay, so this is an example of a keyword. So we should not use this keyword class for any other purpose. Alright, so these keywords or the reserved words cannot be used for any other purposes in the program. Example, a class, the word after the class is the name of the class, right? The way we have it here. Public class welcome. So public is also another keyword, and we'll look at this keyword in the next slide. And in fact, I can give you some hint that we have different class of keywords. So this public thing that you have is called access modifier. This is a keyword which belongs to the class of access modifier. Class means in the category of access modifier. Alright, so let's move on. So here in the slide you have most of the keywords which exist in Java. So well, you can have a look at all these things, and just to keep in mind that you should not use these as your own variable names or identifier. Now, what are identifier and variable names? I will explain that in the next few slides. But these are reserved, right? Reserved words or keywords. These are reserved by Java for its own interpretation, and we should not use these keywords in our program for any other purpose than what they are meant for. Okay, so abstract, assert, boolean, break, byte, all right, while. So most of these things we will be using in CSE114, and yeah, you will get the confidence once you start using these keywords. But since this is the lecture on basic programming concepts, so we should have some idea about these keywords. Okay, now to the modifier. So as I showed you in that program, public is an example of a modifier, access modifiers. So what's the purpose of these modifiers? Why should we have modifiers in Java? So what will happen by using these modifiers? If you use a specific modifier, then that modifier will impose some restrictions on the usage of um, a class, right? So as an example, let me take you back to the example right here. Why did we say that our class welcome is public, right? We could very well in place of public write anything else. So when we wrote public class welcome, then we made a statement, or we declared our class welcome as one which is public. Public means we don't want to impose any restriction on this class. This class is easily accessible, and it can be accessed from any other program. So we are kind of telling the Java like what kind of restriction do we want to be imposed on this class welcome. When you say public, that means no restriction. It is available to access by other programs or other classes. So public is one example which is very lenient, very liberal. Anyone can use this class. We have other other modifiers also, like public. Whenever we talk about public, then related with public is private, right? So you can make it right. Public means if public is generous, open to everyone, then private is just the opposite of that. Private means you cannot access this class or data member or method from outside the class. Okay, so the public is just the opposite of private is just the opposite of public. Okay, so fine, we have looked at public and we have looked at private. Public means no restriction, private means total restriction. You cannot access anything which is declared as private in the class from outside that class. Okay, right? So with these examples, let's have a look at the definition of modifiers. So Java uses certain reserved words which are called modifiers. And what's the purpose? They specify the properties of the data, methods, and the class. So classes, we know about class because we have written one. We do know about methods because if you remember, we wrote the main method. And the main method is also written something like that. So let me write the header of the main method. We write main method as public, right? We start with public static void main, and then there's something we write here, and then that's how we write the block for the main method. Now the important thing is how are we declaring main method? So main method is also public. Alright, so public means no restriction, you can access this method. Okay, so static is another thing. We'll get to static later. It's a little early to get into static, but this is also a modifier, right? You can see here static. So when we'll discuss the classes, that time I will introduce you to static. Then it will make more sense to understand what is static. So when I say that when we discuss classes, that means when we will start starting the real object-oriented programming, and that time we will discuss class in detail, and we will use class to create objects. Alright, so till now, let's not think too much about static keyword. Just make sure that your header of the main method would be just like this. Whenever you are creating your main method, you will always start with the access modifier as public, and then you will say static. Its return type is void. We will we will learn about return type when I will introduce methods to you. For the timing, just keep it in mind that your main method is to be declared in this way: public, static, void, and main, and then you have a string and parenthesis args. Okay. All right. So we looked at public, static, private. Then there is something called as final. Final means anything which cannot be changed. So we use final in declaring um constants. So final has other purpose as well, but let's look at the simplest example. Final is used to declare constants. Declare constants. Constant is something that should not change. Constants. Example, if you are using pi in your program. Pi means 3.14. So if you are writing a program that computes the area of a circle, then you know the area of the circle is pi multiplied by radius multiplied by radius, or pi multiplied by radius square. So here you should not change the value of pi, which is 3.14. So if you have any variable or a value like pi stored somewhere, then you don't want that thing to be changed. And how can we do that? We will use the keyword final. With the example, I'll explain these things to you. Then we have something like abstract. It's little too early to get into abstract, but we will use abstract. So this will when we will discuss the inheritance, which is a very important feature of object-oriented programming. Then in inheritance, when we'll be doing advanced inheritance, then I'll introduce abstract. Protected is another modifier. This will come when we discuss inheritance. So these two things, abstract and protected, will come in our discussions when we look into it will come in our discussions when we do inheritance. So we'll have to wait till that point. But you should understand that these keywords that we have here, public, static, private, final, abstract, and protected, these are all modifiers, which means that these keywords will determine the property of whatever they are defining. So these things can impose these properties on class or on data or on methods. Okay. So now these two important things, like public, what public will do. So if you make a datum, which means the singular of data, so if you can declare something as public, whether it's a data or a method or a class, then it means that it can be accessed by other programs. We are not imposing any restriction on that. But if you make something as private, and mostly we will be making data as private or methods as private. Classes we don't make private, because if you make class private, it's kind of useless. So when you say something as private, then it means that you cannot access that data or methods from outside the class by any other program. Good. So let's move on to the next slide. Okay, so this is a very important slide where we will look into the concept of variable, class, methods. So we will have to use variable, we'll have to use class, and we'll have to use method. So we did not use variable yet, but we have used class, and we have used method as well. We wrote a very simple program, the welcome program. There we had a class defining that program, which was named as welcome and was saved in welcome.java program, the Java file. And then in this welcome class we had a method which was main method. Now all these things, whether it is a variable or class or method, they all should have name. So name is very, very important in our program, because we need to refer to our program. Okay, just like the way we all have name, I have my name, all of you have your name. So the reason why we have been given the name is so that other people can call us. We can identify each other by our name that we have. Similarly, if you're writing a program, you will be using variables, you'll be writing class, and you'll be writing methods. So in order to refer to a specific variable that you created, any class that you have written, or any method you have written, you should give them names so that they can be accessed. Alright, so that's the main idea about this slide. Like, how should we name these different components of our program? So before we do that, let's look at few important terms that might occur in our Java programming class, which is CSE114 API. API stands for Application Programming Interface. So what is an API in Java? So, well, a good thing about Java is that a lot of work has been done for you. So there are predefined classes that comes with Java, and if we want to use those, then we just need to import those predefined classes or interfaces which are written for us to be used by us. Okay, and all these classes that are predefined and are provided to us are in fact libraries, so you can call them library as well. So what is a library? Library means a collection of the code which is written for us to be used by us if needed. So we will start using some packages which are provided by Java. So similarly, we have the APIs. It stands for Application Programming Interface, and these APIs are in fact the library code which user can use, and these are predefined, pre-written, and we should just know how to import these things and how to start using. So that's API. Alright, so as I was saying, that we need to know how should we name our variable, class, or methods. Okay, so what we can have, this is important, right? Naming the variable or the class or method is important, because if you are writing your own methods, own variable, own class, then you should name those. Otherwise, if you have to use some existing class or method or variable which is already predefined in API, then you should know those names, right? And who has given the names to the classes or methods or variables in API? Well, the people who designed this API, they have given some meaningful name to the classes, to the methods over there, and to the variables that exist there. Okay, so that's the reason it is important to know how the naming is done in Java program. So when we say that we have to give some name, then we say that we have to find out the identifiers. So names are also called identifiers in Java, right? Identifier is more general. So when you are saying that we have to find a name, then that means you have to find the identifiers. And the identifiers you will be finding out for these three things: variables, classes, and methods. So whatever name you give to the variable or the class or the method would in general be called as the identifier. So let's try to find out, like, how can we declare our identifiers, like what is the rule for the identifier, and let's see some example where we might use an identifier. So here, this is a simple section of a program. We don't have the complete program, but let's try to understand what do we have here. So this my variable thing that you see here, right, this is not a keyword. Okay, so if you look at the list of the keyword, you won't find my variable, because this my variable is an identifier. All right, it's an identifier written by the programmer for her or his own purpose. Okay, so what is this identifier doing? This is an example of identifier which is for a variable. What is a variable? Variables we need in our program so that we can store some data. Alright, so since the programs are would be mostly working on some data, so we need to store that data in our program. So variables, let me write that note right here. what is a variable? Variables you can consider as the containers, right? Container for data. So please, this is not a technical thing, okay? This is my own description or explanation of container. So variable you can treat as a container for storing our data that we might need in our program. As an example, suppose that I'm asking you to write a program which will compute something like this. If I give you x, then you should compute x square. Alright, so that means you will be giving me x and I will compute x square. That's the deal. Now the point is, whatever you are giving me as an x, so what x can be changed, right? So initially you'll give x is equal to 2 and you'll check whether I'm giving you the correct x square or not. Then you'll give me x is 3, x is 4, so on and so forth. So what will happen is that you will change the value of x. Since you will be changing the value of x, so it is called variable. X will change. It is up to you what value you put in x. Alright, and whatever you are giving in x, I should be able to compute x square. So the purpose of x right here is to store the value that you provide to me. So when you're giving 2 in x, I should be able to store 2 in x, and then I should be able to do x square. When you provide 3 to me, then I'll keep 3 in x and I'll make square of 3, which is 9. Similarly, when you give me x is equal to 4, I'll do square of 4, which will be 16. So that's the purpose of a variable, to store the data. Okay, so right here we are declaring our variable as my variable. So rather than calling that x, I'm giving more meaningful name to my variable. I'm calling it my variable. Now there's something right here. This is another keyword, int. So int keyword, we have a slide that discusses the integer data type, but just to explain this code to you, whenever you declare a variable, right? So this is called a declaration, because this is the first time when this my variable thing is appearing in your program. So what you will say, to whichever variable you are declaring, you should specify its type. Okay, so you should tell that, this container that I have, ultimately these variables are container. So you should tell your program that in this container, what kind of value will I keep? Okay, so is it an integer value that I want to keep, or is it going to be a decimal number that I want to keep? All these things should be told to the compiler. So right here we are saying that the my variable, which is a variable we are creating, its type is integer. So in my variable, I'll be only keeping the integer values. I will not put any value like 2.35, no decimal value. Okay, so decimal is not allowed for integer. So that's the declaration we have done here. Okay, now since you have some value stored in my variable, you can play with this identifier or a variable. So what are we doing here? You are saying that my variable is equal to my variable plus 1, which means that when 5 is being assigned to my variable, right? Let's solve the right hand side. This is how statements are executed in Java. So what will be the impact of this statement, right? This is a statement. Why? Because it is terminated by a semicolon. Every statement is terminated by a semicolon in Java. Right here is our first statement, which is the declaration statement. Why do we call it a declaration statement? Because that's what we are doing here. We are declaring a variable. Its name is my variable. Its type is integer, and we are assigning a value of 5. So in fact, this can be broken down into two. We will look into that today itself. But right now what we are doing, we are combining two statements into one, which is perfectly fine. And this is the declaration statement. The second statement that you're looking at right here is an assignment statement. This is also an assignment statement because we have this assignment operator, but don't worry about it. I don't want to overload you with too much of information on this slide, but just in case you are interested in knowing what is going on in these statements. So when you do something like this, right, so for right hand side is first computed, and then whatever value you have on the right, you compute on the right hand side would be assigned to the left hand side. So the result of this statement is that my variable was 5. So what we did, to 5 that we got in my variable, we will add 1, so that will make it 6, and now the value of 6 would be assigned to my variable. Okay, yeah, so that is the impact of these two statements that you have written. But the main thing that we want to communicate to you in this slide is that you created a variable, okay, which is in general term which will be called as an identifier. You use the identify my variable, which is the name to the variable that you created, and you assign a value of 5 to that. Alright, so let's move on and let's look at some rules, like what names are allowed and how should we name our identifier. So we can use letters and numbers. Only the letters and numbers are allowed, and you are allowed to use the underscore. Dollar is allowed, dollar character is allowed, but only for special cases. So I'll say that you should avoid using it unless you are writing something very complex. Alright, so mostly I'll say that you should use letters and numbers. Now with number also we have a rule. The rule is that your variable name or the identifier name should not begin with a digit. Alright, if you have to use digits in your identifier, then that should not be the first character in your identifier. Alright, so we have some examples, and I'll use those examples to give you an idea like what is allowed and what is not. Now uppercase and lowercase letters are considered to be different characters. So for that I can write a section of code to explain to you. Assume that, right, assume that I am declaring two integer variables, integer x, right, this is lowercase x, and I can also declare integer x, this is capital X. Alright, so the lowercase and uppercase are treated differently in programming in Java. So small x is one variable and capital X is the other variable. These two are not the same. So uppercase and lowercase letters are treated differently in Java. Okay, so keep that thing in mind. Now let's look at some examples and try to figure out like why are these valid identifiers and why are these invalid identifiers. So here this is perfectly fine, right? All that we are using are letters. Everything is letter here, so we are good. How about the second case? You have a letter, all these letters, and you have an underscore, and underscore is also allowed. How about the last one here? My, where, and we have a digit here, but the digit is not the first one. Our first letter of this identifier is M. Okay, so the first character is M, so for that reason M is a letter, so we are fine. If it was 4, then that was a problem. So all these three examples of an identifier are valid identifier or legal identifier. Let's look at these examples which are illegal. So if I ask you why is this illegal, then you should look at all these rules. All these are characters, right? And this is a digit or a number, and you said that letters and numbers are allowed. But the problem is right here. Okay, it cannot begin with a digit, and you're starting with a digit 4, so this is not allowed. Okay, so this 4 that you have here is not allowed because that is a digit. It cannot, your identifier cannot begin with a digit. How about my class? Here we have a problem. Why? Because you did not connect these two, right? Seems like you were creating a composite variable name or identifier name. Alright, so this is not allowed. Please don't leave any space. Look at what is allowed. So allowed says that letters and numbers and underscore, it doesn't say that a blank is allowed, right? So the blank is not allowed, and blank is also considered as a character in programming on Java. So you have a blank character, and blank character is not allowed. Okay, so because of this thing, a blank, this identifier is disallowed. You cannot have a blank character. So if you really want to keep these two things separate, then instead you should be using an underscore the way you have it here. Now why is this not allowed? This is not allowed because of the reason that you are using exclamation character, and this is not allowed for identifiers. Similarly, you're not allowed at the rate, and you're not allowed hash. You're allowed dollar, but you're not allowed these two characters, right? For that reason, the last identifier is also illegal. Cool, let's move on. Okay, fine. So we did learn about the basic rules, like what is allowed in an identifier name and what is not. So now we have conventions. Conventions means that what is the common practice that people follow in writing Java program. So the practice is that the variables and methods that you have, their name should start with the lowercase letters. Okay, as an example, x right here, it is a variable. So variable name should start with lowercase letter, which is x here. It is perfectly fine. Now toString that you're looking at here is a method. It's a method that we will learn to write as well. So this is fine because we are starting with a lowercase letter toString. And this rule is only about the starting letter has to be lowercase. We do have S, which is an uppercase, but that's not the first letter of this name toString, so we are good. Classes start with the uppercase letter. So if you follow these conventions, then you will understand that if an identifier is given to you, you can guess that if he's writing person in this way with P as a capital, then that means it is most probably a class name. Alright, so classes should always be named in such a way that the first letter is capital. So if you remember, then when I wrote this first demo example, then I had WS capital in welcome. Why? Because I want to stick to that notion. So I will recommend you to start using it. Okay, so when you are doing your exercises, when you're doing your lab, and when you're working on the homework, then there also you should try to stick to these naming conventions. Whenever you are writing a class, then make sure that the first letter of the name of your class starts with a capital letter. Okay, fine. So variables and class identifiers should generally be noun. Okay, so variables. Okay, so as an example, suppose that, let me look at this thing, right? Okay, I have the example. So variables name, variable, I gave you some idea about variables. We need variables so that we can store some data in our program which we'll use for the computation. So pay attention to this statement. What are we doing in this statement? So pi, you know what is pi? Pi is this constant value 3.14. What are we doing here in this statement? Let's pay attention to the right hand side first. Pi multiplied by radius multiplied by radius. So when you look at this word which is radius, you will understand what radius is about, right? So probably this radius is the radius of a circle. Okay, so we know what is the radius of a circle, and if the value of the radius is given to me, assume that somebody gave me a value of radius as 5. So I'll put 5, 5. So how do I compute the area? Area is equal to 3.14 multiplied by radius multiplied by radius. That will compute my area of the circle. Great. Now let's look at this radius thing. Radius is noun. Alright, so that was the point. The variables and class identifiers should generally be nouns. Generally these are nouns. Okay. Example, welcome. Yeah, I'll consider welcome as noun. We can consider welcome. Similarly, person is a noun, right? Student is a noun. So we can write these classes. In general, these classes and variable names would be nouns. And method identifier should be verb, right? So we'll look into that, right? When we are writing methods, we'll figure it out. Just have some idea about it, right? It's not very hard and fast rule, but some general guidelines, like usually this is the case. Okay, so method identifiers should usually be verbs. We use camel notation, right? So this camel notation is interesting, and camel notation applies to the compound variables. So what is compound variable? Let me tell you about that. So alright, so when you are creating some variable, then sometimes it is sometimes we can write a variable like radius. So radius is not compound, because if you have to define the radius, you will simply write radius. And assume that I am writing a program where I need to store the number of hours. Okay, so when I have to store number of hours, then how should I write? Okay, so I have number of hours in day-to-day life. That's how I will say number of hours of an employee. I want to keep that information, like how many hours an employee has put on, so that I can find out the salary for that person. So if you have to declare a variable that should be storing the number of hours for an employee, then this is a composite, right? Composite, because when I'll be creating this variable, I want to keep number and hours, at least number and hours together. So the variable that I'll come up with this would be a composite variable, where I'll have two words. Right here it was singular, just the radius was fine. I don't need anything else to define radius variable. But in this example, to have a meaningful variable name, I need to keep number, and this number applies to hours. So I have to think about combining number and hours, right? So how do we do that in camel case? So in camel case, we have two rules. The lower camel case, LCC, lower camel case. So what do we do in lower camel case? We do it this way. I will say number, hours, H will be my capital. Number hours means number of hours, so no gap. This could be my variable, number and hours. This is composite, because if you look at this variable, then it is composed of two words, number and hours, but I need to club these two together. So in lower camel case, your first letter of the variable starts with a lower one, and the second word that you have of this composite identifier should start with a capital letter. This is lower camel case. Similarly, you have an upper camel case. In upper camel case, you will start with even n as capital. You will say number, hours, HOURS, no gap here. So that is the camel case, because it resembles the camel's structure in the back of the camel. So we call that as camel case. So if you apply the camel case rule, then for variables you apply lower camel case. Alright, so for variables we will use lower camel case. Lower camel case, because you're starting with M as lowercase, Y and V, which is the first letter of the second word in the composite variable. So you will keep that as capital. Now for classes, we use upper camel case, right? So upper camel case is for classes, for class names, and lower camel case is for variable and methods. Okay, two string. This is lower camel case, right? T is in small, O is in small, is lower case. then S is the uppercase. Okay, so I think these points are making sense to you. Now, although it is legal, but we should not start with underscore. Please avoid using that. And we should be using the descriptive and meaningful name for the variables. Like if you have to write a program which will be computing the area of a circle, then let's better call the variable area for area and radius for radius. So an extreme case is possible where you might say that, x is my area, and pi I will use as, maybe p, and then radius I'll call as y, right? So if you write this way, this is correct too, but this is not readable. Why? Because I don't know, looking at your program, like what is this x for? Okay, and I don't know what do you have in p. Well, if I look at your whole program, I'll figure it out. But if you would have written the same statement in this way, where in place of x you'll say that what do I have in x, and if you declare that in this way, in place of x you write area, then in place of p you write pi, in place of y you use the variable as radius, then this will be more readable than compared to what I have here. So that's the point. Use descriptive names, descriptive and meaningful name. Alright, so if you are creating a linked list, better call that linked list. Alright, okay, let's move on. Now let's try to understand the statement that we have used in our program, which was welcome. So in the welcome, if you remember, I used just one statement, which was System.out.println. Let's try to understand, like, why did we write it that way? What was system there? Why do we have periods there? So interestingly, this one statement that we have used, it has three parts in there. Alright, one part is system, that's your first part, out is your second part, and println is your third part. Okay, so if you were paying attention to my lecture till now, then you should figure out that right here in the system, S is capital, right? So any identifier that starts with a capital letter, then it means it's a class. Alright, so out of these three components of the statement System.out.println, system is a class, right? So system is a final class. Don't worry about final, we'll get to that later. It's a class, and this class is defined in a package, right? So that package is java.lang package. So let me give you some idea about packages. In Java, we keep we arrange similar classes in a package. Alright, so that's the way to organize our program and the classes. So what has been done, all the related classes are put in one package. So the system class that we are using in System.out.println, it belongs to a package, and the name of the package is java.lang. Alright, so the system that we are using, it has already been written class given to us by Java, and that is in java.lang package. Fine. So what is out here? So out is a member, right? So when we'll start writing our class, you'll realize that in the class we can have some members as well. So in this system class, out is an object, right? Out is an instance, that means object as well. You will learn these details. I mean, when we do classes and objects, you'll get even better understanding of these things. But just for, I'm trying to help you out to the max I can at this level. I know you'll be curious to know everything in detail, but that's the best we can do right here. What is out? Out is an object of type. Every object has a type, right? So the classes, we use classes to declare objects. Okay, so the class is print string, is a class, and out that you see here is an object of type print string. and this out is a member of the system class. All right, good. Okay, so out is a static member of the system class. Now what is println here? Println is a public method which is defined in, it should be defined in the print stream, that is in the print stream class. So println is a method which will print whatever argument you pass on to this method. Alright, and there's another interesting part which is ln. This ln that you see here means that it will add one new line to the output. Okay, so what I should be doing right now, I should give you a demo about System.out.println. Although we have done it, but I want to add one more detail to I want to add some more information to what we have done till now. So, well, this slide that you have, I'm not sure that you'll be able to get 100% understanding of System.out.println, but you should get some idea at least, like why do we write it as System.out.println. You should know that it has three parts. System is the name of the class, out is a member in this class, and this out is of type print stream class, and then in this out or the print stream class we have a method called println, and we are calling the println method for printing the argument. So till now we have been printing some messages. Okay, so let me take you to the demo. So I'm using the same program that I used in the previous class, System.out.println. Alright, and let's print something out. Hello, first line. And now I should compile this. Java C welcome dot Java. Let's say welcome. Okay, so see, because of the new line thing that you have here, ln, what happens is that after printing the statement, which is hello first line, you can see a line here. So this is an empty line that println adds. So println method will add one new line. Ln means new line to the output. So this line that this space that you have here, that you can see in the output, is because of ln thing. Now we have another version of printing. The other method is print, just print. So what this print will do, this print method works just like println, but it will not add any new line. So since I have made this change here, I should compile it and then I should run it again. See the difference. Alright, the difference between this output where you are running using Java welcome, you are invoking the JVM, and the result is hello first line, and then you have a space. This space that you have, or this empty line that you have, is because of the ln thing that we had earlier. What I did, then I changed this program. In place of println, I wrote just print. So what is the result? See the difference here. Now you don't have any empty line after the output. What you see is just this thing. Alright, nothing in between. So this is the difference between print and println. So if you want, I can maybe make some change here, and second line, and right, line, and then I should have fourth line. But let me try ln here, ln and ln, just to give you some idea like what will happen if you use ln. Okay, let's compile this, and now I will run. So see what happened. First line got printed, and after that no space. The second line got printed just next to that, right? First line no space because you don't have ln. So the second line got printed just after that. Hello second line. And here also, even in the second print statement that you have, I'm not using ln. So the result would be that the third print statement that you have would follow what you had here. So you got hello third line. But the third print statement that you have has an ln. Ln means it will introduce one line. So because of the ln thing here, the next thing that you're getting printed out, which is the fourth line, will start on the fourth line. And after that, since you have ln here, there will be one empty new line added to the output. So that's the difference between println and print. So you can try all these things if you want to. That's interesting actually. And the best way to learn programming is through practice. It's just like, learning to ride a bike. You cannot, learn biking or cycling by just reading textbook. You have to practice it. Same is true about, programming as well. Practice is needed. Do it yourself. Alright, so let me tell you another interesting class which you will have to learn to make your program more flexible. So this class is scanner class. So I will use an example to tell you how to use scanner, and then we should be doing a demo as well. So scanner is a very important class. You should learn about it. Not too much of detail, but at least you should be comfortable in using scanner class. Alright, so what is the purpose of the scanner class? So if you remember, this welcome program that I have written is not taking anything from me, right? So how about this? Let's think about it, right? Let's make that welcome program more dynamic, where the program should say that what is the message you want to print. Okay, so rather than just printing line number 1, first line, second line, third line, fourth line, or welcome to CSE114 or hello world, how about writing a program which will ask the user for a message, right? So when I run my program, the user should say what message do you want to print, and then I should give the message and my program should print that message. So the thing is that we want the program to be interactive in the sense that the program should ask the user for input and then the program should act accordingly. So scanner is a class which will help us in doing that. It will help us in getting the input from the user. Okay, so here there are some methods. So the best way to introduce scanner to you is to show you how you should write it. Then I'll do a demo, and after that we'll go over the lecture slides. So how do we, how should we use scanner? What are the things that I need to keep in my program to use scanner? Right, so this will be a little challenging, interesting, but very, very important. So we need to change our program. We'll have to use import. So what is the purpose of import? Well, scanner is a class which is available in Java, so we should know how to use it. Right, so whenever in some cases, right, not in all cases, in some cases, like in case of scanner class, we need to instruct the Java compiler to pull that class for us. So how do we instruct? We call Java to import that class. So let's write this import statement. So the first statement that you will have in your program has to be a import statement. Import java.util System.out.println. That's how you will import. See, this is a comment I'm doing. Import scanner class. This is very important. So the first line should have import statement. Import java.util.scanner. You need to specify complete address of the scanner. So this scanner class that you have is in java.util package. So Java has a lot of packages, as I told you. So we have one package like java.lang. Right, so you remember when I was telling you about the system class? So that System.out.println, there the system class is right here. System class is defined in java.lang package, and we don't need to import anything for the system class, because java.lang is automatically imported when you run that compiler. I mean, you don't need to import anything for system. Java.lang is automatically imported. But for scanner, you'll have to import it. You should say that import java.util.scanner. Now I will not write the complete program. There is a class and all that thing. I'm only writing the statement like how should you use scanner. So scanner is a class. So what we will be doing, we will use scanner as this way. Scanner, the name of the class. We will declare an object of the type scanner. So how should we do that? Scanner, the name of the object, which is up to you what you call it. I usually call that as stdin, which is standard input, is equal to, then you use this keyword new, scanner system.in. I will explain few things to you. Right? Understanding everything will need some time. Again, this relates to the concept of the classes and objects. So scanner right here is the class which is defined, which is scanner class that exists in java.util package. And what is stdin? Stdin is the object, or you can call the instance of the class scanner. So you're declaring it. This is your object that you have declared. It could be anything else. You can call that as input or whatever, right? So this is your own identifier. So let me put that as an identifier or variable, whatever you call. Its type is scanner class. Now how do you create an object? For that you'd use a keyword new. New is a keyword. Scanner is also a keyword which refers to the scanner class. Scanner, and then this system is the same system that you have in java.lang, but we are calling that as system.in. So what is the system.in? It refers to your keyboard. You need to take the input from the keyboard, right? So the user will be providing input using the keyboard. So that's the reason, and the argument of the scanner is system.in. Okay, so this you need to import, and after importing you will have to use scanner class to create a variable of the type scanner. Then what you can do, now you can make use of this object stdin to get the value from the user through the keyboard. Now interestingly, in this scanner class that you have, we have some interesting methods which are used to get the input from the user. So what I'll do, I will use all these things, whatever I'm explaining right here in the program, demo program that I'll be writing. So let's define message. What is message? In the message I want to get in the message variable, this is my identifier, I want the message from the user. Okay, and whatever message I have, I want to print that out on the screen. So I need to declare the type of this identifier message. Alright, so the type of message should be string. Okay, string is another class. And a string is a class which is provided to store some values like this. Right? So example of the string would be the sequence of character. So we can have different kinds of data in Java, right? Like int. Let me give you some background. Int will have values like 1, 2, minus 10, 100, all the whole numbers, plus and minus. The double, don't worry, I have a slide on these things. Double will have decimal values like 2.5, minus 3.75, all these things where you have decimals. And string is different, right? So string will have the values like John Smith, that is a string. And that's one example. That example could be Stony Brook University. These are example of string. And what is a string? String is sequence of character. This is a sequence. Sequence is important. If you mess up with the sequence, it won't be stony anyway. The word will change, the meaning will change. So the string, in a string data type, we have these, text kind of data. This is the text data, right? Stony Brook University is text. These are numbers. When you have whole numbers, the data type is integer, int. When you have decimal number, the data type is double. Alright, good. So for my purpose, I should declare message as a string. Fine, you declared message. Now I need to use this variable to get I will use this variable to store the message that I am getting from the user. Now the point is, how should I get that message from the user? How should I prompt the user to input some message? I will use this object or the variable that I created here in this way. I'll say std in period. So I will use one of the method that we have here. I will use next line. Alright, so next line, whenever you have next line, then when you run this program, then at this line, the program will prompt me to input a message. Alright, and then we'll write few other things, but this was the main these are the main points actually that I want to tell you about scanner class. One more time, import scanner by using the statement import java.util.scanner, then create a scanner object and make use of that scanner object and its next line method to accept the input from the user. Alright, so now I should take you to the demo. I will keep these things. Okay, so let me change this program. And please, follow the way I'm writing. First thing that I should be doing is import java.util.scanner. Good. And after that, let me declare. It's up to me how do I do it, and sequence is not very important here. Message. Alright, what is the purpose here? I'm commenting out here. I'm commenting so that if I share this code with you, you will understand why I'm doing it. So created a variable for the message from the user. Okay, so that's the comment. Okay, so what should I do here? Let me make use of scanner class. Scanner std in is equal to new scanner system.in. Okay, see, I'm careful in every statement, whether it is line number 5 or line number 6, I'm terminating that with a semicolon. Otherwise, that will be your compiler error. Created scanner object. Alright, so now what I should do, actually this is something you might learn through practice if you have not done programming before, but let me give you some insight. So what will happen, I want to give the user some message, some prompt, so that the user will know what to do. So here I will prompt the user by this message, System.out.println. I will pass on this message, what message you want to print. Okay, so here I will ask the user to input, to provide the message, communicate. I'm asking the user to tell the user that, now whatever message you want to give, please type that out. So after this thing, the user will attempt to type, but when the user is typing, we should be able to capture that. So how do we capture that? For that we'll be using this object, which is stdn. So what should I do? I will use this container. Whatever the user is typing, I want to store that in this variable, stick variable, which I have created here. So how do we do that? stdin dot next line. That's the method I will use. Okay, so what will happen here? Now because of this method, which is next line, stdin dot next line, it will get the input from the user. Whatever the user will type would be captured because of the next line method that exists in the scanner class, and that message would be copied or stored in the message method. So now what should I do? System.out.println your message is, okay, message. Now the way I'm using it, it is possible to do. What is happening and why is it happening that way? The details will be explained in next slides. Okay, so don't worry about it. Like, this is one string, your message is, and after that your message will be printed out. I am doing string concatenation. Don't worry, all these things we will discuss when I teach you strings. So there will be a lecture on strings. Strings are very important component of Java program. Alright, so let me run this program and then I'll walk you through this program. Java C welcome.java. Cool. Happy that we have no errors in there. Java welcome. What message you want to print? So I want to print the message that Java is fun. Good luck. Okay, so see, I got that message. Your message is Java is fun, good luck. So this is more flexible, I'm getting the, it's interactive. I'm getting to print the message that I'm typing in. So here's something I did not like. Here was this line, so I can remove that line by making it print. Let me save that. I should save, and then I need to compile that again so that this change is reflected. Compile, and then let's run. Okay, so the previous statement was Java is fun. Let's change that. Java needs practice. Okay, so your message is Java needs practice. Alright, yeah, good. So one more time, let me explain to you this program, which is some 11 lines. Since you want to have the interaction with the user, you need to keep this scanner class. So here, importing the scanner class, which is self-explanatory, but just if you want comments. So you imported scanner class, which is in java.util package. Then you have written this complete class here. Okay, public is a keyword, import is a keyword as well, a class is a keyword. Now this welcome is an identifier. Okay, why? Because I can change this name if I want to. Welcome is something I have given. It's Java doesn't mean anything if you write welcome. There's no keyword with the name welcome. Alright, so fine. This whole thing is defining your class welcome. Then inside that I have a method. Okay, so that method is being declared as public. It is static. Void is the return type. Main, right? So this is the header of the main method, which will remain same. Okay, when you write main method, most of the cases you're writing it the same way. Then you need the argument in the main method, which is an array of the string. Array is something we will learn in 1 week. I believe we will need at least 1 week to, or probably maybe 2 or 3 days. So we'll have to wait for arrays. Then args, but these things will be fixed. You won't have to change anything in this line, right? And why we are writing in this way, I'll explain to you once we get to arrays. Now I declared message as a string variable because in the message variable I want to store the message that user wants to print. Okay, so this is I should also write this thing, variable declaration. What you're doing, you have a variable named message and it's type being string. That's what you're declaring. So this is variable declaration. Then there's another variable declaration where you are declaring std_in and its type is the scanner class, the same scanner class that you have here, and being an object, right? So whenever you create an object from a class, you use a keyword new. Alright, and you use the same name of the class as scanner with parentheses, and right here what you see, this is a constructor. So when you create an object for a class, we call a constructor. But these things will come, don't worry about these details. Okay, when we do class as an object, I will introduce the constructors. Alright, so we created a scanner object and then we are using that scanner object to get the input from the user. But it's a good practice that print a statement telling the user that what do we want. So if you don't have a message right here, then the user would be clueless. User won't know what to do. So when you print a statement like this, which I consider as prompt the user for input, say, just tell the user that, you know what, I am waiting for some message, please type in your message. Okay, so it's a good practice to have a print statement there. After prompting, the user will enter some message, and that message would be captured by next line method, which we have in scanner class, and then we are simply printing that message. And this is an example of string concatenation, which I will explain to you when we get to the string lecture. Okay, so I'll take you back to the lecture notes. Alright, so this is what I explained to you before doing the demo, and you will find the similar notes in my lecture slides also, which is about how to use scanner class. So you must include import java.util.scanner at the top of your source code file. That's what I did. And in order to create a scanner for use, you will have to do something like this. So the thing which is different right here from what I did is just the name of the variable, right? In my code, in place of my scan, I had std_in. Alright, that is just the variable name. You can change, you can write that as my scan, you can write that as an input, doesn't matter, that is your own variable. But make sure that whatever variable name you are keeping, first of all, it should be as per the rules, And the second thing is that it should be meaningful. It should convey that information that in this object that you're creating, there's a purpose. You want to get the input from the user using this variable. Then you'll have to use keyword new, and then this is the constructor for scanner class. What will happen? It will create a reference to scanner object, right? So reference is an interesting thing. So reference means address. So there are two kinds of variables in Java, or the data types in Java, I should say. I mean, again, we can declare data types as primitive or reference. So this thing that you have, MyScan, is an example of reference variable. So reference variables, usually they refer to some address rather than the actual value. Okay, so yeah, whenever you have the class of variables, like MyScan is the variable of scanner class, so its type would be reference. So reference means address. Okay, so it creates a reference to scanner object and tells the scanner to read from the keyword. System.in means keyword. Alright, so now we have the example of using scanner. So what we did, we created S as a scanner object. Now it has even a different name. It is no more MyScan. It's just S. That's fine too. Now you are prompting the user to input the temperature, and when you say next int, that means you will be taking an integer value. Right, so in my example I said next line. Next line means a string, a message. If you want some input from the user that should be an integer, then you should call the method next int. Alright, and the second example we have s.nextLine. Next line for the string, which we have already done. Okay, one more thing. I believe I should go back. Yeah. So the scanner class that you have, it has different methods which you should be using for different purpose. Next line is for string. Next is int is for integer. If you want to take to accept the integer from the user, then you should call next int method. If you want a decimal value, then you should call next double. There are other functions as well, or methods. We call these as methods in Java. So it all depends what kind of input do you want from the user, string, integer, or double. Okay, so we did look at variables, but let's see. Now the variables are the noun of the program. They represent piece of information. That's the most important thing. They represent pieces of information. Okay, so they represent pieces of information. That is that is the case. And you can also write the same thing in a different way. You should say that they store the data which is to be used by the program. Alright, so if you have something like this, integer radius, then that means this radius name that you have given in your program, it will be storing the radius value which we can use for computation of area, or maybe circumference. And the variables, they come in different types. Okay, so if you remember, we have already looked at one variable which was of type string, right? So string variable we have already used. This was used for the variable like message. Okay, so when you say string, then it means that in the message we will have some value like Stony Brook University. This is a string which is a text. Alright, and now these values that you have, these values are called, see, this is a variable. To this variable you can assign any string. So right now you can probably assign this value by using this assignment operator, which is equal. So in the message you'll have Stony Brook University. Now this thing that you have, which is Stony Brook University, this is called a literal. That means a value. So literal right here is Stony Brook University. So that is the value which is being assigned to message. So the literals are assigned to the variables. Okay, so this was a string. You can also have int type. Int means integer type. So if you have to declare an integer type, then that is declared using int. I is small. And similarly we have long as well. So it depends, like how big is your integer. If your integer is really big, too big to fit in int, then you should be using long. Long is another variable type or the data type which we should be using for a variable if we want to store a really big integer in that variable. So int or long. Now character, which is denoted by char, is also a data type which is used to store one character. Alright, so here if you look at Stony Brook, then that is a string, and a string is defined as a sequence of characters. So here in this message string that you have one character which is capital S, then small t or lowercase t, uppercase S, then lowercase o, lowercase n, lowercase y, and then you have a gap which is a space character. Then you have uppercase B, uppercase R. Okay, so if you want to store a sequence of characters, then you should declare that variable as string. Otherwise, if you want to work on one character at a time, then you should be declaring the variable as char. So you will say char my char is equal to, now it is up to you, what do you want to assign? You may say F is a character. Now you should have noticed that when I'm well, before that, what is A and F? These are the values which we'll be assigning to the variable of type character, and this A and F, which is a value, is an example of a literal. This is character literal, and this was string literal. String value is a string literal, character value is a character literal. And if I say something like this, int x is equal to 5, then this 5 is an integer literal. It means a value. So literals are assigned to the variables. Okay, now if you pay attention that the character literals are enclosed in single quotation, whereas the string literals are enclosed in double quotation. Okay, so this is something you should keep in mind. Alright, now how do we declare the variables? So in Java you need to declare your variables before you start using that. Now the question is, why should you declare? Because every data type that we have in Java is associated with some operations. So when you tell the Java that this is an integer variable, then from that Java will figure out like what are the allowed operations that you can perform on an integer data. Similarly, if you like this one, if you declared message as a string, then the Java will know that since this guy is declaring message as a string, so I know like what methods we can apply on this message variable, and the methods which are defined in string class can be applied on this. Okay, so this is important. So that's the reason you should declare the variable. Java requires you to declare a variable before you use it. Why? Because this will tell the Java like what behavior to expect from that variable. Okay, now the point is, how should you declare? So in order to declare a variable, you should have a type followed by the variable name. Okay, so I can write this general statement, which is you should have first write the type of the variable, and then you should have a variable name. That is the general statement, like how will you do that. First mention the type and then the variable name. So example, int, that means the variable that you see after this thing would be an integer one. So you can say my int. Alright, so my int that you have, it is of integer type. So this is type and the name of the variable. Similarly, double, my double. Alright, so my double is a variable and its type is double. So you can store a decimal value here, but so if you do my double, there's no space here, is equal to 3.5, then you're fine. That is allowed because my double you have declared as a double, right? So decimal is allowed. But if you do something like this here, if you say my int is equal to 2.5, then that is a problem. Why? Because you are saying that your variable my int is of type integer. So in integer we don't have the space for a decimal point. Alright, so that is the point. That's the purpose why you should declare your variable. Java requires you to declare your variable before you use it. Why? Because it will tell Java what behavior should we expect from it. How do we declare a variable? The way we have done it, the type followed by variable name. So this statement is declaring x to be an integer variable. The second statement is declaring pi to be a fractional number. Okay, let's move on. Now what do these variables do? They store data. Okay, that was the definition I was giving you earlier. The purpose of the variable is to store data so that we can process that data. Okay, so now as I mentioned, there are primarily two types of variables that we have: the primitive type variables and reference type variable. So what's the difference? In the primitive type, the example of the primitive type is char that you see right here. Then we have int, we have byte, we have short, long, then double, float, and boolean. These are the example of primitive type, right? And what is a primitive type? So in primitive type variables, they store single piece of information. What does that mean? Look at this example here. So letter is the identifier name. It's not a keyword, it's your variable name letter, and the type is character, char, and you are putting a value in the letter, which is A, the capital letter A. So this is just one piece of information, which is letter A, capital, and that is enclosed in the single quotation mark. Good. Similarly, if I have to create a variable like double, let me say double y is equal to 3.45. So what is happening here? Y has one piece of information, which is a decimal value of 3.45. Okay, so in the primitive data types, you will have single piece of information. And there's one more thing about the primitive data types or primitive types, which you will learn in the next lecture. In the primitive type, you store the original value. Okay, so let me add one more point right here, which you will see in the advanced chapters. In the primitive type, we store original value. So if you say y is equal to y plus 2, then what will happen? The value that you had, which was 3.45, y would be 5.45. You'll add 2 to that. Alright, so the Primitive types, they will store the original value. First thing, they will store one piece of information, 3.45, that's it is. That's the decimal value. Similarly, letter has A, that's just one value. And the other point is that they store original value. At the location or the address which is being designated by letter, you have just one value which is A. Letter means A. Whereas in case of reference type, the example of the reference type is string. Okay, string is a reference type. Okay, so what does that mean? Let's look at the value that goes into string. So you declare string text is equal to ABCDEFG. And the example that I had is, let me take it back, Stony Brook University. So here in the message you have what? 1, 2, 3, 4, 5. 5 characters, then a space character 6, 7, 8, 9, 10, 11, then a space character 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So you have 22 characters in Stony Brook University, and which is in fact the string literal. And in the message, if you see, then in message you have 22 or 24, I forgot what I counted. So these many information, so it has more than one bit of information, all the characters. Okay, so a variable stores multiple pieces of data. A reference variable stores multiple pieces of data. Okay, so as an example, string, what is a string? It's a sequence of potentially multiple characters. It's a sequence. This is important. B is coming after A, C is coming after A and B in this order. Alright, and in the text, if you look at, then we have 1, 2, 3, 4, 5, 6, 7 characters. Alright, and as I added one more point, I will add here that this reference type holds address, not the original value. Okay, primitive data types, they will hold the original value, whereas reference types, they hold the address of the value, not the original value. Okay, good. So now let's look at some variables. So the variables, they must be declared with the type, and variable type will determine what kind of values that variable can hold and how much of memory will that need. That's something we are learning, right? It was not there in the previous slide. So what we knew from the previous slide was that when you tell the type of the variable, then from that we will know what kind of value the variable will hold and what operations we can perform. The type of value that a variable can hold and the operations that we can perform on that variable or that value. Now the most important thing that we are adding now to our discussion is about memory, like how much memory we will need for a specific data type. That's an interesting thing, and the next few slides will give you an idea about the size of the different data types. So character needs 2 bytes, right? So if you declare something as character, then that means that Java compiler will store 2 bytes for this character variable. Integer has 4 bytes. Double, I think, has 8 bytes. String depends on the size. Objects depends on the size. So let's find that out, right? So here we go. Now for primitive data types, right? Let's look at the primitive data types and try to figure out that what is the size which is being set up for each data type. So we will look at first the numeric data type. So in the numeric data type, we have 2 broad categories. The one where you will represent for whole numbers, and the other one is for real numbers. So let's look at the whole numbers. For whole numbers, we have byte, short, int, and long. So byte is used to store really small integers. So if you have your integer that is in the range of -128 to 127, then you should use byte. You should declare that as byte. Okay. So you will declare it as like byte x is equal to maybe 5. This is good. 5 is in between minus 128 to 127. If you have to store 255, then probably byte is not the way to go about it, because 255 is out of the scope of 1 byte. And byte in fact is of 1 byte storage, 8 bits, the smallest uh, you know integer data type. Then the next in this sequence is short, and the short is 2 bytes. 2 bytes means it has double the size of a byte, and because of double the size, which is 2 bytes, that means 16 bits. You can store the integers in this range, which is minus 32,768 to 32,767. Okay, now integer is 4 bytes. I just want to say, okay, I was correct there. 4 bytes, it's double the size of the short, and you should see the range also. So this range is considerably higher than the range of integers which you can represent using short. So this idea you should have in mind, right? You are learning Java, good. So it's good if you know the size of the data types, because you will need that information. If you're writing a program about integer, so you should know like what is the max value that your integer can attain. So on the basis of that, you should pick the appropriate data type for integer. Long is the biggest data type for integer, which is 8 bytes, double the size of integer. Now you should see the range. This is much bigger than what we have with the int. Now for real numbers, we have two types: the float, which is 4 bytes, and then double, you have 8 bytes. For characters, you have 2 bytes. Okay, and now this is a Unicode thing which I'll explain in the chapter on characters. So this is an encoding actually. Every character that you have on your keyboard has a code associated with that, right? So A, like the capital letter A has some, as far as I remember, it's 65. So every character that you have on the code has an associated number assigned to it, which is called its code, Unicode or ASCII. So we'll look into that later, but the message is that for character data type you will need 2 byte. Okay, then we have another very interesting data type, which is Boolean. Boolean we use to store true or false, and this is very handy. Very soon we will look into the Boolean, probably in my next lecture when I'll discuss the conditionals. So Boolean is also a data type which will store just two values, true or false. So it kind of stores the value which would be a decision, right? As an example, x is equal to 5. Is x greater than 3? Right, so the answer to that is true. Yes, that is the case. Alright, so these are some conditions which are evaluated, and the result of the evaluation would be either true or false. So that kind of a result is stored in Boolean variable. Okay, so now if you're interested in the range of values that we can store in float and double, then this is the slide for you. And the message is quite clear, which is about the range of double. Look at this. So here it means 10 raised to the power 308. Right, so this is in the scientific notation minus 1.79 and these many decimal places into 10 to the power 308. Okay, whereas with the float it is 0.38. Now often students, they ask this question like, why do we call it double? So float is called single precision, whereas the double is called double precision. So why is this single and double? If you remember the size, right? So the float is stored in 4 bytes, whereas the double is stored in 8 bytes. So in a way, if you are looking at the number of bits and bytes, then the capacity of double is twice the size of float. So the precision that we will be achieving would be double in terms of the number of bytes that we have for double. So that's the reason it is called double precision. I want to do a demo here to give you some idea about the difference in the float and double. So let me use the same example. I will erase everything here and let me see. Let me declare double x is equal to 10.0 divided by 6, and I'll say float. Oh, well, let me declare this as float. Float x is equal to, I will write f. I'll tell you why I'm doing it this way. Double y is equal to 10.0 divided by 6. Alright, then I should have System.out.println x. Okay, and System.out.println y is y. Let's run this thing. Okay, so see, I got a compiler error. What is it saying? It is saying that on line number 8, semicolon was expected. So if you try, if you have patience and if you look at the compiler at the errors that you're getting, then these errors are sometimes very helpful. So I could figure out from here that there's something missing in my line number 8, and the problem is that I don't have a semicolon here. That's what I have. So I'll go to my line number 8 and I'll fix that by putting a semicolon. I should save this and I will run that again. Java, welcome. Okay, fine. So look at the the result. That's the output. What is x? X is a float. Alright, and what am I doing? I'm computing 10.0 divided by 6. So if you divide 10 by 6, then it is 6 once, and then you get 40, and every time when you divide 40 by 6, after the decimal, you get the same result. 6 times 36, you get 4 again. So this 6 that you have after 1 is repeating. So this repeats. So now look at the value that I got. I declared x as a float, and we know that float has 4 bytes, whereas double has 8 bytes. So now when you print the same value, which is 10.0 divided by 6 for float and also for double, look at this thing. X has the precision after decimal till how many places? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay, so how about y? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so look at this precision. For double, I have more number of decimal places as compared to the float. So you should get some idea about double the precision. Means that with the double, you will have a higher precision. I have intentionally used this example where we have repeating 6 at the decimal place. Okay, so this should give you some idea about the fact that when you have double variable, then you'll have a higher precision after the decimal position. Okay, so I have a similar example in my lecture slide also, so if you want to try out, you can try that. So in this test I have 1.0 divided by 3. You may ask me, like, why do I have an f here? Well, the reason for that is that if you just say 1.0, then by default 1.0 is treated as double. I want this value to come out as float, so I am saying 1.0f. So if I say 1.0f, then 1.0 would be represented in float. Otherwise, if you leave f out, then it will assume that it is in double. Alright, so this was the difference I found. You can try the same and you should find similar output. Now, to variables, like how do we assign value to the variable? So you should declare the variable and you should also give some value to the variable, otherwise you will run into trouble. Okay, so maybe I should add some comments right here. Let me give you some example. So usually what we do, usually you should start this way. You should say integer x. You declared x to be integer, and semicolon is important, right? And then you can do an assignment. Assignment means we will give some value to x, 10. This is called assignment. This is important, right? So you should declare and then you should assign some value to x, and only then you can use x. After that, if you want to print, you can print x, or you can maybe add some value to x. But you can do something like this: x is equal to x multiplied by 2. This is the multiplication symbol. This is only allowed once you have some value in x. Alright, if you don't keep this thing and you start doing x is equal to x multiplied by 2, that's an error. Okay, so assignment is important. The variable should be given some value using an assignment. And this operator that you see here, which is equal, from mathematics, it is called assignment operator. How does it work? For an assignment operator to work, first we compute the right hand side. This is to be computed. So if you right here, we don't have to compute anything. That's the value 10. And once the right hand side is computed, and then this value is assigned to the left hand side. So what happened? 10 was assigned to x. Now let's try to understand the second statement, which is assignment again. Whatever we had in x, which is 10, is being multiplied by 2. That makes it 20. Now this 20, this is something you'll do first, which is whatever you had in x, multiply that by 2, which is 20. So you compute the right hand side. Then 20 is assigned to the variable, which is x, and x takes the value 20. Alright, so these two statements that you have, this guy and this guy, these are called assignment statements. Alright, so let's look at some examples and try to understand like what is the rule and what we should be ideally doing. Now let's see, what do we have in this method? So public, we know what public is. It is the access modifier. Void is the return type, and that's the name of the method here. Look at the way we are declaring the method. It's the lower camel case method with a good declaration. So what do we do here? Salary is a variable which we are declaring as double. That was the declaration, and here we have the assignment or the initialization. Okay, so we should initialize that variable salary before we use it. Okay, so salary was initialized to 20,000. Now if you want to print the salary, you can pretty much do that, because you have declared salary as well as initialized salary to some value. You can print it out if you want to. How about the second method now? Public, same way, void, and then the name of the method. what are we doing? Well, this is a problem. Why? You're saying salary is equal to 20,000. Fine, you are doing an initialization, but the initialization should come after declaration. Where is your declaration? Right? So first you should have declaration the way we have it first, followed by the initialization, which is wrong here. Okay, so in fact it should come this way. Declaration should be your first statement followed by initialization, and then you should print it out. Good. Now variables can be declared and initialized at once, right? So this is perfectly allowed. Character, yes, character is equal to y. So this part, the left hand part is declaration. I should say from here to here you have declaration, and from here to here you have initialization. So you can combine these two into one statement. So all these examples that you have here are the examples of the statement where we have declaration as well as initialization. So which is perfectly fine. Now let's see what do we have here. Public void method with good reference. What does it mean? You are declaring here double salary and then you are initializing as well. So from the previous slide we learned that the declaration as well as initialization we can put in one statement. After that what we did, we computed raise. So what is raise? Is a double variable. How do you compute raise? Raise is simply the salary multiplied by 5% amount, which is 0.05. Okay, so it is very systematic. You first declared salary and initialized as well in one statement, and the second statement you are computing a raise on the salary, and you know that the raise should be 5%. Straightforward. And then you are printing it out. Alright, good. So how about the second case here? You have double salary. Okay, you declared it, and now you are using raise. You are computing raise on salary and multiplying that by 0.05. Alright, but what do you have in salary? Right? So the problem is that you don't have any value for salary. You are missing initialization. You are missing salary initialization. That's a problem. Alright, so we need to fix that. And all these things will result in compiler error. Okay, so what do we have here? Let's see. So here everything is fine in the green color. You have double salary, which is 20,000. You are printing that the salary is 20,000. And then what you did, you're using the same salary variable and putting a different value in that. That's perfectly fine. So what will happen in this variable where you had 20,000 initially, which you printed out, now you are assigning 60,000 on the same variable. So what will happen in this container, which is salary, in this salary you were keeping 20,000, but when you did an assignment right here, then this was the first case, right? When you are doing the second assignment, then 20,000 value would be erased and it will be overwritten by 60,000. So when you print into the second System.out.println, then it will print 60,000. Why? Because this 60,000 will erase 20,000. Okay, and there's no issue at all with the compiler. Compiler is perfectly fine because this is something which is allowed. How about this case? You have double salary 50,000. Cool, you can print it out. Now what you did, you overdid this thing, right? Since we have already defined salary variable right here in the very first statement of this method, we should not redeclare, right? So the problem is with the redeclaration. You don't need to do that. You declared that once and that was good. Alright, so you have declared right here. You should not declare that again. That's a problem. That's a compiler error. Alright, if you really want to redeclare for some reason, then you should rename it. You should call it salary1 or something else. You cannot have the same declaration multiple times. You cannot declare the same variable multiple times in the program. Declare means the name associated with its type. Okay, even if you change its type to integer, even then that is not allowed. You should not have one variable name in multiple declaration in the same program. That's a compiler error. Okay, now there's another interesting thing which relates with the scope. Okay, so what is a scope? Scope has to do with the visibility of a variable. That means till what length of the program you can use that variable. So let me explain that with the help of the example. So in this example that you're looking at, public void method with good scope, look at x. It is double declared in the first line, and we are using an if statement. Don't worry too much about if. In the next lecture we'll be doing if, which is a conditional. So value of x is compared to 0.0. 5.0 is greater than 0.0, so condition is satisfied, and you print this statement out. Okay, and you're printing within the program, right? So x, this x that you're declaring right here is visible in whole of the program. So you're perfectly fine. You can print it out because x is declared right here and its scope is the whole program. You can print, no problem at all. Now let's look at the other program here which we have written. Double y is equal to 100. So y is visible in whole of the program, right? If you want, you can access y anywhere in this program. Let's see, if y is greater than 0.0, which is the case, right? Y is greater than y is 100, which is greater than 0.0. So what you did in this block, right, in the if block, you declared a variable x which is of type double and its value is 5, right? Now you're trying to print x outside this block, so this will not work. Why? Because this x that you have defined is only accessible in this if statement from this point to here. If you had this statement at this place after double, after this statement within the if block, then you were fine. The very moment you come out of the if block, the scope of x is finished. X is only accessible in this if block. Alright, because that's where you have defined x, that's where you have declared an x, the x variable. The very moment you come out of the if block, you are out of the scope. Now outside the if block you cannot access x because x has a scope which is the if block. Alright, so that's the point. Variables can only be used inside the block or the scope that they themselves are declared, right? So the scope of x is this block, right, which is an if block. Outside that you cannot access x. If you're doing it, you'll get a compiler. Alright, so let's look at some assignment statements. So how does a assignment statement work? You'll have a variable on the left hand side and you will have the equal operation, which is equal from maths, but here we'll be calling this equal as assignment operator in Java programming. This equal is your assignment operator. Okay, good. So how does it work? So whenever you have an expression means something like this. You know, if you have assume that int variable and int x is equal to 2. So the expression could be x multiplied by 5, right? So this expression is first evaluated, which means if x is equal to 2, let's multiply that by 5. So this expression So you first solve a evaluation first, right? So this is the thing that we do first, and then assign the resulting value to the variable. Okay, so let's try it out on the example. What will happen here? Here the expression which is the right hand side is a constant expression which is 5. We don't need to evaluate anything, so 5 would be assigned to x. We are done with the first assignment operator. How about the second one? So here we know that x is 5, so we'll have to compute the right hand side, which will be evaluated as 5 plus 5 plus 5, which is 15, plus 10, which is 25. So when you're printing x, you should get 25. So the point is, first you evaluate the right hand side, and then in the second you do the assignment. Okay, so now let's look at one more interesting thing, which is about variables compatibility. So that means that when you are making an assignment, then the variable that you have on the left hand side should be compatible with the value that you have in the expression. If there is a compatibility issue, then you'll get a compiler error. So let's look at the example. Okay, assignment compatibility. The variable and expressions should be of the same type. If not, you may get a compiler error. So see, what do we have here? Sum grades is an integer, grade x is an integer, grade y is an integer. So you might find this statement little strange, but it is allowed. When you have to declare multiple variables of the same type, you can do it. If I have x, y, and z, and which are all integers, then I can pretty much do int x, comma y, comma z. X, y, z, they were all integers. So in place of declaring them each on a single line, I can combine those declarations into one line. Right? So in place of 3 such declaration, I can put everything in one line. They are to be separated by a comma. That's what we have done here. So this statement is good. Sum grades is integer, grade x is integer, grade y is an integer. So if you say grade x is equal to 1, you are fine, right? Because grade x is of type integer, you put an integer value. Sum grades is equal to 1473, perfectly fine. This is an integer, you can assign it. Sum grades is equal to 1472 plus 1, that's fine. You can add these two integers, the result would be an integer. Integer assigned to an integer value, perfectly fine. Similarly, this statement as well, sum grades is equal to grade x is 1 plus 1472. This is good too. But what is the problem right here? Sum grade is of type integer, true is boolean, right? Boolean value you are assigning to an integer variable, which is not allowed, right? So here we don't have the compatibility problem is there. Compatibility problem. Alright, so it will raise a compiler error. Okay, so this is an interesting thing which is about numerical operators. So numerical means when you are dealing with the int, you have the list right here. When you deal with the variable types and values like byte, short, int, long, double, and float, then what will happen? And this forms a very interesting scenario. So there is a rule actually. When you have expressions involving different kinds of numeric data types, then what will happen? So Java does something interesting actually. So this rule is about that. So let me explain that with an example. So well, it has to do with a situation like if you have let me give you an example which is outside the programming domain. Assume that you go to a coffee shop, and in coffee shop you have the cups like this. This is the smallest cup, and then you have a bigger cup, medium sized cup, and then you have the biggest cup. All right. Okay, good. So let me call this small, medium, and large. And you went to the coffee shop and you said that, I need a smallest coffee. The coffee that you need is of smallest size, right? But there is a problem in the coffee shop. They are out of, they don't have the small cup anymore. What they have is medium and large, right? But you need the smallest quantity of coffee. Okay, so in this case, I think we don't have a problem. Why? Well, the person at the coffee store will very well, pour the smallest quantity of coffee in either of these two mugs, right? So what will happen? You need this amount, but we don't have the smallest cup. So what will that guy do? That guy will put just this amount of coffee in either the medium cup or maybe the larger cup, right? That's perfectly fine. There won't be any overflowing condition and you will be happy, right? It will be little inconvenient because the cup is little bigger than the amount of coffee, but it is manageable. You can do it. So that is something Java does. Whenever it allows for the smallest value and the smaller value to be assigned to a larger variable type. So this case is allowed. So let's try to understand. Here x is of integer type and we have a value 5 in there. Now what are we doing? Y is of type long, x is 4 bytes, y is 8 bytes. Long has 8 bytes. Now you are assigning x to y. X is an integer which is 4 bytes, y is a long which is 8 bytes. So should we allow the assignment of a smaller type to a bigger type? The answer is yes. Why? Similar situation, right? There won't be any overflow. We have more space. We have twice the space to accommodate 5. Alright? So these assignments are okay when the lower type is being assigned to the higher type of variable. How about this? Should we allow the long to be assigned to double? Yes, pretty much. Why? Because double is decimal representation and decimal representation has better way of representing big numbers. So if you're confused about this rule, then I'll say that you need to follow this order. What is this order saying? This order has this, this information that smallest is byte, then you have a short, then integer, then long, followed by double, and then float, and then the double. So you can assign a byte to short, byte to int, byte to long, byte to float, and byte to double. Alright, but it cannot be the other way around. So from left you can go to right. You can do this way, you can do this way, right? That's the byte. You can go all the way in the right direction. Similarly, short can be assigned to int, it can be assigned to long, to float, to double, but not the other way around. Similarly, int can be assigned to long, int to float, int to double, long to float, long to double, float to double. Okay, so this kind of assignment is allowed, but you can't go the back way. Alright, if you really want to go the back way, then you need to do some extra work. Alright, so these three were fine. These three rules that you have are fine. Why? Because int is on the left hand side of long, we are good, and double is on the right hand side of long, right? So we were good. How about this thing? Double a is equal to 6.5. Yes, 6.5 is a double. We are assigning that to double. Now can I assign a which is a double to long? Well, double to long, can I go back? Answer is no. Okay, so you cannot go back. So this order is important. Please keep that in mind, and you can reason as well. So fine, can we do int c is equal to b? B was a long. Can we assign long to int? No, you are going to the left hand side, which is not allowed. Okay, so these are some rules that Java has about assignment involving numeric data. There's an order. So as long as you are following the order and you are doing the assignment from the smaller type to bigger, you are good. So here's the rule. No assigning big types to little types or real type to integer type. So from integer to real you can do, right? So long to float you can do, long to double you can do. So integer to real you can do, but from real to integer it is not allowed. From float to double you can, from float to long you cannot do, from double to long you cannot do. Okay, so this should be my last slide in this lecture, which is about the fact that if you really want to do it, right, if for some reason you want to convert from the higher type to lower type, then how should you do that? For that we have the concept called as casting. So how do we cast? For that we will have to use parentheses. All right, so if let's take this example, what casting does, let me read that. Casting does a type override. What does it mean? It temporarily changes the data type to another type, temporarily, right? So how should you change the type? You need to put the new type in the parenthesis. All right, so let's take an example. Your double myreal is 10.0, which is a real value. Now you have int bad int and you try to assign that real into int. It will not happen, right? You'll say, okay, 10.0, so I don't want 0, let 10 be assigned to integer, it looks like an integer. No, it won't work that way. Why? Because when you assigned 10 to a to a double variable, then it was stored as a double, and now you want that to be assigned to an integer. It will not happen implicitly. You will have to do that explicitly. What does that mean? You will have to use casting, right? This is casting. And how do we do casting? You will have to specify like to what type you want to want this number to be changed to. So you'll say integer. So let me do one interesting demo on this, and then that will be it for this lecture. I should go back to the example right here. Let me done that again. CLS, and I'll just make one modification to this program. Alright, cool. So let me try doing this thing. Int c is equal to x. Okay, so what is my intention? X is float. I want that to be assigned to z. Z is my integer. And let me see. Sorry about that. Control V. Here I should say z. Okay, let's see. Now when I'm compiling, I'm getting an error, right? So what is this error? Read the error and try to understand. Error says that incompatible types, possible loss of conversion. Float to integer, right? That's the problem. You're trying to convert float to an integer, which is from real to an integer, which is not allowed. Where exactly? This is happening on line number 9 and in this statement. Okay? Line number 9 in this statement. Now, if I really want to do that, then I should specify that explicitly using int. Right? Casting float to int. Alright, so now let's try this out. It worked, right? It worked because I did that casting. Good. So one of the reasons why I wanted to give you this demo is to realize the fact that what is going on behind the casting. So casting is not rounding, right? So take this message, it is very, very important. Your x is 1.6666, all right, and you're casting x to integer. So what happened? If that was some kind of rounding, then it should be what? 2, because it is 0 0.6. 0.6 is more than 0.5, so it should be rounded to 2. But that did not happen. So what instead happened was truncation. So casting results in truncation. Whatever you have after the decimal is lost. Okay, so casting actually does the truncation. It does not do any rounding. Alright, so I will stop right here and I'll see you in the next video lecture. Bye bye. Take care.